Hey guys, welcome back to Crack Code. Today we're doing another Brainstellar Quant puzzle. This one is called Catching Ants. It's a medium problem. You guys can pause and go over the problem once. So what's given to us in the question is we have this 1 by 5 square card and also this 1 by 1 square table in front of us. And we also have been given 51 ants placed on this square over here on this table. Now, I'll be calling the ants as dots because they're geometrically the same thing. So, what the question is asking us is that given any random placement of the 51 dots on this 1 by 1 square table over here, is it always possible to pick a 1 by 5 into 1 by 5 square on this 1 by 1 square, which would be covering at least 3 dots, right? So let's say a random arrangement of the dots was something like this. Now, if I pick a 1 by 5 into 1 by 5 square as this one, then I'm only covering 2 dots, right? So this is not the goal. We have to guarantee that no matter what the arrangement is of the dots on the 1 by 1 square, we can always be able to pick a 1 by 5 into 1 by 5 square covering up at least 3 dots, right? So to give you guys a few hints about this problem, first of all, try to think about the fact of how many 1 by 5 into 1 by 5 squares can fit inside a 1 by 1 square table at maximum. 1 by 5 into 1 by 5 is basically 1 by 25, and that would mean that there's 25 squares that could fit inside a 1 squared bigger square, right? So that arrangement would look something like this. So here I have this 1 by 1 table over here, and I've made 25 smaller squares, each of 1 by 5 into 1 by 5, right? So this is how we would divide 1 by 1 square into the maximum number of smaller cards squares, right? So this would be important in just a minute. So why did I make this? Now let's call each of these smaller card squares as a slot, right? So now I could modify the question to the question that can we place the 51 ants in the 25 slots given over here such that no slot has more than 2 ants? Let me pause over here and think why this question is basically the same question as the original question. So this is the new question that we're asking, right? And this would lead us to the answer, right? The answer to this question will actually lead us to the answer of the original question. Why? Well, if we say that this is possible, then in that case, the answer to the original question is that we can't guarantee. And what are we supposed to guarantee? Well, we can't guarantee that the card encompasses at least 3 ants. What we can't guarantee is that no matter what is the arrangement of the 51 ants, we can't guarantee that in every single arrangement we can always pick one smaller card area which will have at least 3 ants, right? Because this means that there is an arrangement on the bigger square where we can make the arrangement such that there is no slot that has more than 2 ants, right? And if there's no slot that has more than 2 ants, then that particular arrangement won't satisfy our given goal, and so we can't guarantee that we can always do what we've been asked, right? Now, the other case, if we say that this is not possible, which means we're saying that there is no particular arrangement where we can place 51 ants in the 25 slots such that each slot has 2 or less than 2 ants. If this is not possible, then we're saying that there's always going to be one slot that has at least 3 ants. And that would mean that we can guarantee that no matter the arrangement of ants, there is always going to be a slot that we can pick out which is going to have at least 3 ants, right? So now you guys can try to think about the entire problem and come towards a solution. So the solution is actually just the pigeonhole principle, which we've already talked about in earlier videos. The pigeonhole principle, well, again, is just a fancy way of saying the following. So since we have 51 ants, right? So now what we're trying to do is to have the ants as separated as possible. If we keep all the ants together in, let's say, the entire square, well, we could just pick this square over here, right? So our goal is to try to make sure that the ants are as separated as possible. Well, the best we could do is for the 50 initial ants, and since we got 25 slots, we could assign 2 ants to each of those 25 slots, right? So that way, for each of those slots, each of those 25 slots, now there's 2 ants, right? And all of the slots are filled with 2 ants. Now, since we have 1 ant left, and there's no many slots left with less than 2 ants, this 1 ant is going to have to go into a slot which already has 2 ants, and that slot is going to end up having 3 ants. So by the pigeonhole principle, because with 51 ants, it's impossible to make sure that each slot has less than 2 or equal to 2 ants. At least one slot is always going to have 3 ants. We have confirmed that we can guarantee, no matter what kind of arrangement of the ants in the bigger table, there's always going to be a slot which is going to have 3 ants or more. I hope you guys understood the solution, and thanks for watching.